we are finding the inverse of g of x equals 2x over 1 minus x so that we can find the range of g of x. So we've started by replacing our g of x with y, and then we've traded our x's and y's, and we just talked about the best way to get rid of these fractions. We decided cross multiplying might be the best way to do that. Okay, so I made this out into a fraction so I wouldn't get mixed up when I'm cross multiplying it, even though that 1 doesn't really do anything. So that will give me x times 1 minus x times y equals 1 times 2y. I want to double check because I do make mistakes. Make sure you agree with what I've written down. I distributed the x through and I multiplied it, right? So that both terms are multiplied by that x. Okay, now what I want to do is gather all my y's on one side. It doesn't matter which side. However, if I move the y's to the right, then that's all I have to move. But if I move the y to the left, which actually might look better, then I would also need to move the extra x to the right. So I feel like maybe just moving one term to the right would be best. So let's go ahead and add xy, start writing it too. Add xy to both sides. And of course, adding xy is not a like term. So we can't actually combine 2y and xy. They're just going to be two separate terms on the right side. And that takes it away from being on the left over here. I'm out of room, so we're going to come up here. Okay, so now I have x equals 2y plus xy. I'm trying to consolidate all of the y values into one y so that I can solve y. So what can I do to this side of the problem so that I have y kind of more by itself? Do you see how we can just factor that y out now? And think about the terms. So factor it out. Y, and we have 2 plus x. Yeah, so it's undistributed factoring. Now what? Our last step here to get y by itself. So this means y times 2 plus x. There you go, we're dividing. So we're dividing it by 2 plus x, right? So in other words, our inverse is x over 2 plus x. Okay, now our whole purpose in doing this problem wasn't necessarily to find the inverse, although that was a bonus. It was something that they usually ask you to do. This problem wasn't phrased that way, but that doesn't mean that finding it was the wrong thing to do. Oh, it does say find the inverse, never mind. Okay, we're using that to find the range, right? So remember, the range of the original function is the domain of our new function. So let's think about the domain. What can x not be? 1. So in our original problem, x couldn't be 1. But now we have a new problem. So what would make that denominator 2? So x cannot be negative 2. So in a nutshell, I have room to summarize this. For g of x, the domain is x cannot equal 1, and the range is y cannot equal negative 2. For the inverse of g, the domain is x cannot equal negative 2, and the range is y cannot equal 1. Because they're inverses. The domain and range trade. The numbers are the same, but the x's and y's are traded. And that is very helpful. Knowing the domain and range is especially helpful to kind of figuring out what the graph looks like. Because these particular graphs are rational functions or like reciprocal functions. And so the domain and range actually tell us where the asymptotes are. So if we know the range, then we know where the horizontal asymptote is as well as the vertical asymptote. It gives us both asymptotes and makes it easier to graph. Okay? All right, one more problem. Graph the following functions to show that they are one-to-one and find their inverses. So earlier I talked about the fact that a parabola is not one-to-one unless you restrict it. So look at what's happened here. What have they done to this parabola? In fact, this is the same exact parabola we graphed earlier. I don't know if you recognize it, but it was the same exact one we did earlier. We completed the square, so we rewrote it as x minus 1 squared plus 3. So if they're saying x is less than or equal to 1, that's because our graph, sorry, I forgot what I already had it drawn out, right? 1 of 3. So our graph is a right 1 of 3, say right there. So there's our parabola. Well, what does restricting it do to the shape of that parabola? What are we doing if we're just saying the piece greater than or equal to 1, or less than or equal to 1? Which piece is it going to be? The left piece, correct? So I'm actually going to erase the right piece out of it because they restricted the domain on our parabola. Now is it a one-to-one function? Yes, it is one-to-one, and now we can find the inverse. So, to find the inverse, we are going to just take our function, y equals x minus 1 squared plus 3. What's the first step? Well, we did the first step. Yeah, trade x and y. So x equals y minus 1 squared plus 3. Now we're going to solve for y. We gradually just need to get everything away from y so it's by itself. So what should we start with? Next thing we have to undo is the square. What are we going to square? Square root. Now, when you put a square root in a problem, you have to do a plus or minus. When you put the square root in a problem, you have to do a plus or minus. Except not this time. Because it's restricted. So instead of it being both the positive square root and the negative square root, it's just the left half. It's just the negative square root. Yeah. So it's just going to be the negative square root of x minus 3 to get rid of the square on this side. We square root both sides, but it's just the negative piece because of that restricted domain. Last step. Yeah. So negative square root of x minus 3 plus 1. Let's think about the transformation. So this is a square root graph. Means it like goes like that, okay? Like half of a parabola, go figure. And it's got a negative, which means it's going to be reflected upside down, yeah. And it's got a minus 3 inside, so it's going to be right 3, and plus 1 means up 1, right? So, right 3, up 1, but instead of it being an upward square root, it's going to be a downward square root. And look at our graph. Reflection over y equals x. So what if you did the positive square root and then you graphed it and realized it wasn't a reflection? Then you would know that you needed to do the negative square root instead. That's probably some of you are thinking, how did you know we needed two negatives for instead of positives for amounts? I mean, I was going with it being the left side, which means it's going to be the negative side of the parabola. But if you didn't know that or graph it right originally, then the reflection will give you that heads up of, oops, it needs to be the other half. It needs to be reflected. Okay, let's go the other direction. This one's not restricted because square root graph is already 1-to-1. So that's awesome. So let's go ahead and change this to a y. Oh, yeah. And then trade x and y. And then solve for y. Okay, just want to make sure we're awake. Carlos, what should I do first?
I think that you need to get the 1 over the other side.
Perfect. So what should I write?
X plus 1.
Perfect.
And then I'm assuming.
Oh, I was going to make Tracy do the next step.
Oh.
So what gets rid of the square? Yeah, so just square both sides, right? Yeah. So we're going to go ahead and square both sides, so we have x plus 1 squared equals y plus 2. Now by doing that, we now have a parabola, which is no longer 1-to-1. And so we're going to have to restrict the domain at some point. And it's a positive square root, so it's going to have to be the positive side of the parabola. But we can deal with that at the end. I'm just trying to keep you thinking about it. Okay, I may what to do next.
Subtract 2 on both sides, or do you want to?
No, we're not. Let's not worry about filing it out. I mean, we could, but I'm not going to worry about it. So just subtract 2. And I prefer to have the y over there. I don't know if you guys care that I did that little switcheroo on you. So there's our parabola. It's moved to the left 1 and down 2. You could multiply it out and put it in a nice, like, standard form if you wanted to, but not necessary. But we do need to restrict the domain so that it's actually the inverse of this square root. So it's just going to be the positive half of the parabola. So if the vertex of our parabola is moved left 1 down 2, then what will the domain need to be just the positive piece? So x has to be greater than or equal to. So the negative 2 is the y side. We're doing domain, so we just care about the x side. Yeah, perfect. So x has to be greater than or equal to -1. So there's our inverse. But we have to restrict the domain in order for it to be the actual 1-to-1 function inverse, because its square root function is already automatically just half of the parabola. But when you have the actual parabola, you have to say that you're just doing half of the parabola, like a piecewise function, just a chunk of it, right? Okay. Any questions? I didn't sketch that one. I guess, oh, it does say graphic. Oh, I didn't even follow the instructions correctly because it says to graphic. I did it all algebraically. It's good for you to see it. So, graphing this one would go left 2 down 1, and it's a square root function thing. And then this one, we said is going to go left 1 down 2. So it's half of a parabola thing. I don't think I put that the right place. So down, left 1 down 2. With that, and up with that. I think sketches are not as good as I would like them to be. And then we can see that that is, in fact, hopefully the reflection over y equals x. Right? So technically this would be inverse of k is equal to x plus 1 squared minus 2. and x has to be greater than or equal to -1. So our final answer for our inverse would be something like this. Okay, so I have something fun. Oh, I have